Alright, let's start on some exercises from chapter 6. Hopefully my mic's in a good spot. We'll see what happens. Yeah, so this is 6.1, so this is the first exercise in the chapter, so it's like probably just like supposed to be a warm-up, but I mean like come on. Like this is a sort of like at this level, I feel like you sort of look at this and you can almost immediately see that this is going to turn out to be true. Because like when you're proving that something is a subspace, there's not really a whole lot of things you have to check. And well, typically if the space is really weird, then maybe there will be like some issues that you have to work out. But when you're looking at polynomials, like polynomials are really nice. So you basically just get started. So what are these spaces? So VQ is just the set of polynomials of degree at most q on the interval of from 0 to 1. Here you have open parentheses. Here the interval is closed brackets. The open parentheses here I think are just like a notation. And then V0Q are the elements in here which vanish at the point 0. So this is a subset of VQ, so in order for it to be a subspace, all you need to do is prove that it's a vector space in and of itself. So let's see here. So that's pretty obvious. What about the zero vector? Well, the zero vector here is the zero polynomial. Just for ease, we'll denote it by z. It always belongs to this subspace VQ because it's a zero element. Because if it didn't have a zero element, then it wouldn't be a vector space. So z is in there, and then, well, z vanishes at 0 because it vanishes everywhere. So it's obviously going to be in V0Q. Now we want closure under addition and scalar multiplication. So you take two function in V0Q and a xi in the real numbers. Then okay, well, obviously, f plus g and xi of f are both going to belong to, that shouldn't be r, that should be vq, right? Right, because because if you add polynomials together, you get a polynomial, and adding polynomials does not increase the degree at all, and so you're fine. Also, if you multiply a polynomial by a scalar, you just multiply that scalar by all the coefficients of each of the terms. And so again, you get a polynomial, and again, this doesn't increase the degree at all. So these two polynomials, f plus g and xi f, both belong to VQ. And then if you evaluate these things at 0, well, taking the sum evaluating at 0, that's just taking f0 plus g0, which, since f and g are in V0Q, are both 0. So f0 plus g0 is 0 plus 0, which is 0. And xi f of 0, well, that's just xi times 0, which is 0. So f plus g and xi f are both elements of VQ, which vanish at x equals 0, and therefore they're both elements of V0Q. So V0Q is a subspace of VQ, which contains the zero vector and is closed under addition and scalar multiplication, and thus it's a subspace. And that's all there is to it. It's a pretty quick problem, and there we go.